Hello and welcome to this tutorial. This is my name's Chris. And I was just going to cover its design templating a 3D model. This is setting up for like if you were wanting to have some sort of scale blueprint of your given 3D model. How you would go about getting things set up for your model so that you could do like scale blueprints that where you could apply that in the process of like actually designing outside of like 3D printing your given model, or using CNC milling if you were actually applying true to scale prints to whatever media that you wanted to use, providing kind of a framework for getting it set up for actual true to scale design. So that's basically what this tutorial is covering, is just setting up the file itself. So what I've gone ahead and done here is I've got a completed model. In this case, I was designing like a Midi pedal board that I wanted to use, and I was needing actual scale blueprints for that. So in order to do this, I needed to kind of reconcile translating that data from Blender, beyond just having like a 3D object file, and where that it doesn't necessarily provide you with like a two-dimensional blueprint, file for each particular part of the object that you're going to design. So starting off from off the bat here, I just wanted to say that like in any given 3D object model design, preferably your design object, if you wanted to create something sort of blueprint, is constructed in such a way that, like the object is broken up into component parts where those particular parts are delineated by like, common sets of faces that are all kind of aligned in a similar way. In this case, what I mean also by that is, and we can see that on the object, the pedal board object here that I've got designed, that one component face is set up in such a way that, and I'm going into edit mode here on the object, and we can see all of the faces have a similar set of normal coordinate axis that are shown. So for instance, if I select each of these faces, they're all kind of aligned and oriented in the same way, and so they all have a similar relative normal axis, for this component geometry. So and if I select other, as it turns out, if I select other components, it's a similar deal. So whenever you're doing design work, optimally, you've broken down the design into component objects that are self-similar in terms of their geometric orientations and their relative axis, so that that it makes it easier for you to be able to, for instance, break that down into and being able to do exactly what I was going to cover in this tutorial, which is being able to export it to blueprint design templating. So in this case, what I'll do is I'll cover the actual conversion of 2D two-dimensional conversion, and this is a top-down projection of a given component object. It doesn't have to be top down, but it's it is a normal projection relative to that particular component's face. In this case, I'm going to be doing, in one case is a top-down projection, which is for the two-dimensional export. So I'll go ahead and start by picking the actual component that we want to work with, which is this, it's labeled top upper 2 in my blend file. And I've gone ahead and selected it. And the one thing that we'll notice is that it is the component itself is at a given angle, or it's rotated slightly relative to the axis, the normal three-dimensional global axis, and we can see that shown below. Let me just go ahead and align the axis real quickly here to the center of the mass so that we can of the object, so that we can see that more clearly. But we can see that for instance, that the object itself is slightly skew relative to the y and the x and the z axis in this case. So let's see, I'm just pulling this up here. So what I'm going to do is we'll need to go ahead, and when you're preparing this object, as it's stated, we want to get this aligned to the given global axis so that we can do like a projective, an accurate projective, orthographic projective view, for the scaling. So in order to do this, if you're starting with a group of component objects, what I recommend is that what I've done is I typically will duplicate the component object that we want to, for instance, like photograph for blueprinting purposes. So in duplicating that, what we would do is like hit Shift D and then drag the component in someplace, out of the view or out of range of where the object exists in its present state. And that's away from, all of it in its assembled state, for instance, if you have a 3D mock-up. So with the object, again, translated, duplicated and translated, we could see that it's still rotated and it's not quite aligned with the existing, say, global axis. And there's actually a trick, even if you don't have like the normal axis remain the same to the global axis, and you're not exactly sure what the rotation of the object is, there's actually a method and way to rotate the object so that it is aligned with the regular axis. And to do this, what we actually do is we'll go into edit mode, and we can go ahead and select a face on the object, and we'll go ahead and select the transform orientation under that, select normal, and we'll notice that by selecting the face, that the orientation of the normal coordinate axis system actually changes to that of the face of the object. This represents this actually represents the rotation of the object, the component object as a whole, the way that we're seeing it relative to, say the global axis. So with that selected, what we'll want to do is go ahead and record, this is under edit mode, record the transform orientation, the normal transform orientation. And to do this, you just select into 3D view properties, just go down to transform orientations, shown here where I'm circling, and just hit the plus button, and we'll go ahead and name this to a given name. I just call it A for now, and just select checkbox use after creation and overwrite, and just hit enter, and that is recorded now. That transform orientation is recorded. That will be important because we'll go into object mode again and get out of edit mode. And what we'll notice is that the orientation is still maintained. I'm just transforming this origin to the center of mass so that we can see it relative to the object better here. And so we have that, and now we can actually apply a rotation, a transform rotation to the object. And when I click object, transform, and then align to transform orientation, the object, lo and behold, is actually flattened out relative to its original position state or rotation state. So then now it looks more like it looks aligned to the global and local coordinate axis, which is what we want, because when we go to do blueprinting, we would either need to match the viewport's planar angle so that it matched generally the face, the normals of all the faces, component faces on that object, or we would have to do what we're doing now, which is what we've done, so that we get an accurate representation of all lines on a two-dimensional flat projection. That even under orthographic view, when we do a flat projection, some of that will get lost. That data does get lost if the object is rotated relative to the the viewport plane. So with this aligned, what we would just need to go ahead and do from there is, and I've gone ahead and hit the period in this 7-pad or numpad 7 to get a top-down view projection. And what we do next is we'll need to convert our coordinates so that they are matched for the rendering, the rendering type according to the scale that we're looking for. Some paint programs like Adobe, Photoshop will do this automatically, or they have conversions between pixel scale resolution to inches or centimeters. Blender just keeps it all in pixels. So we have to do a pixel to inches conversion here, or pixels to centimeters or meters, or whatever units that you're working in. You'll need to do a conversion between those units. It's not really hard to do, but you do have to keep you probably want to have a calculator handy, and you want to keep in mind, the DPI that you're looking for, which is the dots per inches or pixels per inches. In this case, we want to work, if you're wanting to work with, say, higher quality prints, design prints, you're looking at probably 300 DPI, which translates into 300 pixels, say, per inch. So if my design, for the scaling of your design, in this case, if we had 300 per inch and the design was 12.5 inches, we would be looking at 300 times 12.5, which is 3,750 pixels. I also do stress that when we're setting this up, that you'll probably want to add some sort of padding, pixel padding on either side of the object that you're accounting for. So you might want to go ahead and add something like 20 pixels in, so that on that particular dimension. So if we're looking looking at approximately, it would be 3,770 pixels. Now, if you know that the scale of your model is something like, well, in this case, I know that its total depth is something like 5 inches. So we might give ourselves on the viewport when setting this up. We may go ahead and set that up so that we have 300,770. And so we can either keep it at the existing 1080 pixel dimension, but we would probably want it to check and make sure that, if we had 5 inches that we wanted to cover, 5 times 300 would be 1,500. So we'd probably want to, if we know that the overall design is 5 inches, well, this component is less than 5 inches, so we're probably okay keeping it at 1080, but it might be just on the safe side, better to keep it at something like 1,500 pixels, to give us enough space so that we don't potentially have loss of DPI or clipping on that particular boundary when we're doing the rendering work. So once we have that those render dimensions set, and we want it, again, that's under properties, render, you put the X and Y resolution dimensions in there in the pixel box. And usually I select anti-aliasing 16, or 8, at least 8, if not higher, depending on whether you have square lines or skew lines relative to your coordinate axis that are shown. If they're skew, then you may want to increase the anti-aliasing, but if they're generally square, relative to the existing axis, your lines, then you're probably not going to need to rely upon anti-aliasing as strongly. But in any event, the next thing that we want to do is go ahead and scale the image or the object into the viewport. Now we've got it top-down aligned, but we do want to make sure that the object is appropriately rendering in our frame. So what I've gone ahead and done, and it's kind of important, you want to close out the toolbox so that you get the total frame width, in your 3D viewport. So close down the properties tab under the 3D view, so that we just have the viewport frame shown in the 3D view itself. So while we can toggle with our rolling the middle mouse button on your mouse to toggle the object view in and out, I will typically do my rendering like with OpenGL for template printing, just because it's pretty easy and convenient once you kind of know the process in doing so. But the problem with rolling the mouse wheel is that you may see that the object is it scales kind of like in pretty big incremental jumps, depending on how close or far you are from the object. And unfortunately, you don't have kind of anything in between, in doing that. Now, you might be able to use Shift F and use your use the ASDF or ASDW keys to kind of also scroll in and out. But there's another way to actually select a view in a more precise way in this top-down view, and that is using Shift B, which is a view border select, and this allows you to more finely control the viewport selection so that it lines up with the object, the boundary dimensions of the object. Now, you don't want to clip the object as you're selecting those viewport boundaries, and it zooms in, but you want to have it pretty close to the border, give and take a few pixels, for the padding that we've already accounted for in this. So once you have the border kind of selected generally around it, then you can go ahead and at this point, then you're ready actually for the OpenGL rendering. Now we can actually pull up the Properties tab again on we'll want to go ahead and do that so that we can go ahead and make sure that we're just rendering what we need, which is the design and not all sorts of other stuff, that kind of obscures our view of the design potentially. So we'll go ahead and do that. And then under render, just go ahead and select OpenGL render image. Now, depending on how much, whatever dimension size that you're working with, it will take a little bit of time to get that rendered. But optimally, when it's finished, you should have something where the object in the viewport is adequately shown, and that you don't have, for instance, any clipping in the object as relative to the border, and that can be used. So that once you have that, I'm just go ahead and do this one more time. So selecting this. Okay, for some reason we had a little too much width or something that had appeared to have a little bit of clipping, but ideally the borders of the image shouldn't be interfering in the render. So yeah, we can see in this rendering here that it is just the object that is shown. Oh, and we also want to make sure this is an orthographic view. That was probably one of the other reasons why we were having some issues there. So orthographic view, you want to push the number 5 on your keypad. You can tell the difference between orthographic and perspective because you'll see kind of perspective angles coming in that normally don't show up relative to the orthographic view. But it's as we inspect, and you probably want to go ahead and visually inspect to make sure you have a little bit of padding on either side of the object, after you've printed it, so make sure it looks like you've got adequate padding. It doesn't have to be perfect because the Photoshop, whatever Photoshop program that you're working with, if you put the DPI, the resolution, and the dimension size, and you select it, it should give you some sort of, based upon the units that you're working in, when you go to rescale it, accurately to scale specs, as long as you know what you need to scale it to, it should provide you with an accurate data. So you'll just want to make sure that whatever you're modeling, that you know the dimensions of that component, the total dimensions across, say, the width, or lengthwise. So you probably want to record that in some way and keep track of that when you do go to rescale it, in your Photoshop program as you select it. It's probably something I'll cover I was thinking about covering in another tutorial, but for now I just wanted to cover this in the Blender, kind of prep process. So in any event, if the photo looks good, then you just click image and save as, and then save it based on your file type. Don't change the extension of it, and just make sure to, whatever you want to name it, just name it and save it. And you'll need to repeat the process of if the object needs to be rotated so that it matches one of the coordinate axes, duplicating and rotating it, or if it's already in a match to the coordinate axis, just making sure that you have an orthogonal view. So like, for instance, I've selected this side component, side wall component, and it's actually called left side 2 here, and I just hit the numpad period, hit the number 7 to go to top view, and then my arrow key or numpad 6 to rotate it, the view, and then numpad 2 to rotate the view down, so that I have a projective view, that's an accurate representation for that given projective view. And you'll repeat the process of doing that and doing exactly the same steps that I described just moments before, when we did the process of rendering a photo for that. So in this case, just getting that pulled back up. We do Shift B and get it approximately decently in the viewport. If it looks like it's there's a little too much padding space, you can always reiterate the process of hitting Shift B and kind of honing in a little bit closer each time until you feel that you've got an adequate spatial view. Now on this, you may need to change your resolution, although you can possibly keep it the same if you wanted to. You'll just need to make sure that in the conversion process, when you import it into Photoshop, you'll need to rescale it down. I believe, like in Photoshop, if you have the object selected where you don't have anything but the object, for instance, you can select the object using the magic wand tool, and it'll crop it so that that it's going along the border edges, and you don't get any of the background of that, which is a very, very excellent, useful tool, because then you can rescale it, maintaining the same scaling ratio as you rescale it. I believe that's just hitting Shift and then using the marquee tool or whatever in Photoshop and dragging it either left or right. That will allow you to rescale it. And you want to pay attention to, again, recording the desired dimension. So I always recommend that when you model something, that you're always recording the edge, record the edge lengths on the model, so that you at least know one dimension size when you're doing the rescaling. So in this case, like, I have this object selected, and if I have, let me go back into object mode, make sure I have the right object selected. Yeah, so we have the object. Okay, yeah. So get an appropriate view here. So you can pull up, for instance, in the properties under 3D view, you can pull up edge length, and it should give you the edge data information, length information. It's not showing here, but it does work. So then you can select by holding the Shift button, select each, for instance, edge, kind of adding these, and then so like what I've shown here selected, all of those edges, add to the total length across the dimension going across, and you'll want to record all of those edge lengths that are shown and add those up, and make note of that, and so that when you go to rescale it in Photoshop, that it matches that particular length, at least along that dimension or that axis. So, and again, you'll just repeat the process of photoing each of these, border selecting, and again, recording your dimensions. Also, when you're modeling, I showed this, it's under the scene, under the properties. It's properties scene tab. I use metric, but you can also use imperial units, which are like inches, feet, and all that jazz for the imperial units, I believe. And then there's the metric if you're working in metric. I do recommend modeling, using that because that conveniently allows you to see when you're designing all these various components, and it allows you to conveniently see, measure, and record all the components themselves in terms of their lengths, and what is what and what is needed there in terms of all of that. So in any event, that completes this tutorial on what I wanted to cover for this, and I want to thank you for listening in. Thank you.